Greenhouses are very different than soil farming. We've now been able to really optimize a lot of the growth parameters for plants. They're controlling things like oxygen in the water. They're controlling all of the nutrients the plant is getting. They're controlling the amount of light the plant is getting. Greenhouses are susceptible to things like heat stress. In tomatoes, this causes something called blossom end rot. So there's certain microbes to basically help relieve these stress symptoms, allowing their plants to do better throughout the growing season. It's really, really hard to culture a lot of these microbes that you're looking for. So you can do a genetic screen, you can identify the one that you're like, yeah, I think that's going to be like the amazing growth promoter. So these are really complicated systems with a lot of interacting and moving parts. By using machine learning, you can find these patterns and understand how these microbes are working without rationally understanding every conceptual little piece. So with increasing pressures from climate change, it's going to continue to get harder and harder to produce food. We're going to have more erratic weather and more strain on our food production systems. So growers need more ways to sustainably increase crop yields without impacting the environment in a negative way. So at Ceragen, we are developing probiotics for plants that increase crop yields by improving the plant's response to environmental stress. So you can think of these products sort of like anti-anxiety meds for your plants that help improve their response to stress so that they produce more food. There's a few different beneficial traits for plants, like phosphorus solubilization. Nitrogen fixation is a great one, but right now we're focusing on plant growth promotion. Being able to culture these microbes, especially designing mechanisms for culturing the microbes that are very difficult to culture using, say, standard techniques like Petri dishes, is a very unique skill set. Our solution is designed for use in these hydroponic systems. It's very easy to apply. You only have to apply it once to twice throughout the growing season. You use the existing watering infrastructure, so it takes very little time for the growers. We're in the process of developing new products for a multitude of crops. We want to restore the natural ecosystems in that hydroponic environment. If a farmer uses this and applies it to all of their tomatoes, we're going to see an increase in about 8 kilograms per plant. Scaled up to the farm, where the farmer has about 200,000 tomatoes under glass in these hydroponic systems, then that's about 1.6 million tomatoes per year. And if we look at the North American level, where there are 20,000 acres of tomatoes under glass, that's an increase of 800 million kilograms of tomatoes each year. And that's just in North America. Whereas if we talk globally, we're going to be touching billions of lives through billions of kilograms of increased food production. It's like, wow, we have this amazing market opportunity here with these microbial products and the ability to not only make a social impact where we help increase fresh vegetable production so that the people have a more sustainable, better opportunity to access those sort of fresh vegetables, but also to increase the environmental sustainability of agriculture by increasing the amount of food that we can produce from the same amount of land.